Alright, so the last day of notes here is about solving absolute value equations by graphing. Now, remember when we solved systems of linear equations, we said wherever those two lines intersected, if they did intersect, that was going to be our solution. So the same idea here, we're going to look at and see where does the absolute value function cross the other line. So as a reminder, for graphing the line y equals -2, that means on the y-axis you're going to go down 2, and this is your line y equals -2. So we're going to be using that to solve by graphing. So first thing we're going to do is get the absolute value bars by itself on the one side of the equation. Then we're going to graph the left and right side separately, and then wherever the two lines intersect, that will be your solution. So here we have 3 times the absolute value of x equals 12. The absolute value bars are not by themselves, so we divide by 3 on both sides. So the absolute value of x equals 4. Now the absolute value of x, we know how to graph that. It has a vertex at 0, 0, and there's an invisible 1 in front, so that means up 1 and right 1. Up 1 and right 1. And then up 1 and left 1. So this is the left side of the graph, and the right side of the graph, 4. So 1, 2, 3, 4. And we look and see where do we intersect this at. We have two intersection points, -4, 4, and 4, positive 4, 4. So we're going to say, whoops, -4, 4, and 4, 4. Now, letter B, we have to first add 3 to both sides. That will get almost the absolute value bar by itself. So 2 times the absolute value of x equals -1 plus 3 is 2. Divide both sides by 2. The absolute value of x equals 1. So now we'll go again and graph the left side. The absolute value of x, vertex at 0, 0, is going to keep going this way and this way. And then y equals 1, we go to 1 on the y-axis and draw a horizontal line. So our two solutions are at x equals -1, so -1, 1, and +1, 1. Now let's look at these. Divide both sides by 6. The absolute value of x equals 5. So absolute value of x again will look like this. And then 5, 1, 2, 3, 4, 5. That horizontal line. So our solutions are -5, 5, and +5, 5. Now, letter D is a little bit tricky. Let's look at that. -7 from both sides. So -2 times the absolute value of x equals 10. Then we divide both sides by -2. So now the absolute value of x equals -5. So absolute value of x looks like this. And now y equals -5. 1, 2, 3, 4, 5. There's y equals -5. Those lines don't touch at all, so there's going to be no solutions because they don't intersect. So these other three we had two solutions each. Here we have no solutions in letter D. We could have one solution if our horizontal line goes to the vertex. So now let's look at the next page. You'll notice on this one and all of these over here, we have a number inside the absolute value. We're going to do it the same way. Divide both sides by 3 to get the absolute value bars by themselves. Well, we can't add 1 on both sides. We can't do anything here. The absolute value bars must stay intact. So we got to graph that now. Remember, x minus 1 means you go over to the right one, and your slope is still 1, 1. So then we graph it just like this, and then y equals 3, 1, 2, 3. So your solutions should have been right here at -2, 3 and +4, 3. So those would be your two solutions to that one. Over here we have to add 3 to both sides. So we get the absolute value of x plus 2 equals 2. Now again, the absolute value bars are by themselves. We can't add or subtract numbers to the inside of the absolute value. So graphing this, x plus 2 means from 0, 0, we're going to go left 2 and put a dot. And then up 1 and right 1, up 1 and right 1. This is our absolute value graph. And then the other side is y equals 2, so 1, 2. And we have two intersection points again. This one is at -4, 2 and 0, 2. So those would be our two solutions. All right, let's divide this by 8 on both sides. Absolute value of x minus 4 equals 16 divided by 8 is 2. So again, the absolute value bars are by themselves, so 1, 2, 3, 4 in the opposite direction, up 1 and right 1, up 1 and left 1. Now, our slope for all of these so far has been up 1 and right 1 and then up 1 left 1. That will always be the case when we're solving these absolute value graphs. And then y equals 2, 1, 2. So where do they touch? They touch here at 1, 2, 2, and here at 1, 2, 3, 4, 5, 6, 2. All right, and then our last one here, add 2 to both sides. So we get 5 times the absolute value of x plus 3 equals 15. Divide both sides by 15. X plus 3 equals 3. So graphing that left side, 1, 2, 3 over. There's our vertex, up 1 and left 1. 1 and left 1. And then y equals 3, 1, 2, 3. This is our horizontal line, so our solutions are at 1, 2, 3, 4, 5, 6, -6, 3, and 0, 3. So these, all four of these had two solutions because we had two intersection points. So what we're going to do down here is draw an example of each of these situations. If we had one solution, then it would look like this. Going through the vertex, and we would have one intersection point. Two solutions, would look like a lot of the other ones that we did, where we'd have our line touching in two spots. And we did the one that had no solutions. As a reminder, no solutions looked like this, and then had a horizontal line below the V. No intersection points. So again, we have to work and get the absolute value bars by themselves, and then draw the graphs of the left and right side, and wherever the intersection point is, that would be your solution or solutions. So thanks for watching. Make sure to like and subscribe.